Hey, hello and welcome to today's GFG problem. The day hope you're doing well. So let's say today's problem, search in a sorted matrix. Okay, so what the problem is saying is we'll be given a sorted matrix. Okay, and we want to find whether the element X is present or not. So let's quickly see. So here is a sample matrix. Okay, so if you see this matrix is completely sorted. For example, this the element at the last column of this first row, right, is lesser than the element at the second row, okay, at the first column. Okay, so if you see these elements, right, they are completely sorted. For example, if you just write it down, right, 1 5 9 14 20 21 30 34 and 43, all the elements are sorted, properly sorted. Okay, it's not row wise or it's not column wise. Okay, but completely sorted. Okay, now what you want to do is you want to find out this element in this sorted matrix. Okay, so let's quickly see the first of all the naive approach, right? What will be the naive approach to iterate all the elements of the matrix, right, one by one, right, by having two for loops, I equal to 0 to n, then j equal to 0 to m, where n is the number of rows, m is the number of columns. Okay, and you have to find out whether this element, comparing each element with the element to be found, right, x, that is x. Okay, but this is going to take what, O of n into m, which is nothing but O of n square, right? So this is the naive approach. So can we do something better? Okay, so again, since this is the matrix is sorted, and since last few days this um, sorted matrix and searching an element is going on, so definitely we'll be using binary search. Okay, we'll be using binary search, but now there's some trick in order to solve this problem using binary search. Let's quickly see that. Okay, so first of all, so we are going to have a low variable which we are going to initialize with 0. Okay, so now where will low point? Low will be pointing here, low, right? And we'll have a high pointer, okay, which will be n into m minus 1, because we want it to point it to be here, right, at the last element, which is going to be what, n is 3, m is 3, minus 1, 3 into 3 9 minus 1, which will give us 8. So okay, now what are we going to do? What we do in standard binary search, we calculate the mid, right, low plus high by 2, which is going to be 0 plus 8 by 2, which will have 4. Okay, now generally if it would have been the array, right, so what we would have done, we would have compared array of mid with x, whether it matches, right? But since now we have a mid, but since this is a matrix, right, this is a matrix, we cannot directly, because we want, right, uh, two pointers here, right, two pointers. So how are we going to have those two pointers? So we want to calculate the row number. Okay, we want to calculate the row number and the column number. Okay, that is the cell which you want to compare with the given x, right? So there's this trick, or you can, like, it's completely observational. Okay, for example, so how we are going to calculate the row number? So we are going to take mid divided by m. M is the number of column, and for column number we're going to take mid mod m. So it's completely observational. Okay, so you have to observe. For example, mid is now 4, right? 4 divided by m is 3. 3 is the m is the number of columns, right? So 3 is the number of columns. So 4 divided by 3 will give us what? 3 ones are, right? 3 ones are. So quotient is 1. Similarly here, 4 mod 3. Okay. Again, 3 ones are, but remainder 4 minus 3, right? Remainder becomes 1. Okay. So we want to compare the element. For example, mat of 1 of 1, right? Row number, column number with x. Okay, with x. If it is same. So what is mat of 1 of 1? 1 of 1 is this, right? Mat of 1 of 1 is this. Okay. If we compare with, is it equal to x? No, it is not. It is not. Okay. But it is greater than x. It is greater than x. That means, what does it mean? If this element is greater than x, then the element to be searched will be on the left side, right? Will be on the left side. So what are we going to do? If mat of row number, right, and column number, if it is greater than x, right, if it is greater than x, then the element is on the left hand side. The element is on the left hand side. We are going to do high equal to mid minus 1, right? That means our high will be pointing here now. Okay, the high will be pointing here. Okay, Now let's quickly see. Let me erase this again. So low will be as is, right? Low equal to 0. It is here, right? And high is here. What is high? 0, 1, 2, 3, right? High is 3. High is 3. Now we are going to calculate the mid again. Mid equal to 0 plus 3 by 2, which is going to give us what? 1, right? Mid is 1 now. Now we want to calculate the row number again. Row number, let me have this notation. Row number equal to mid, which is 1, divided by m, which is 3, right? M, that is the number of columns, which is going to give us what? 0 only, right? And column number, what you want to do? Mid, which is 1, mod m, which is 3, right? So in this case, 1 mod 3, which is going to give us what? Remainder will give us 1. Okay, remainder will give us 1. Okay, so now we are going to compare the elemented row number, column number. For example, what that will be? Mat of row number, column number, right? We're going to compare. Is it equal to x? So what is that for? First of all, row number, column number. It is 0, 1. So let's see row number 0 and column number 1. So that means 5. We are comparing 5 here, right? So is 5 equal to 14? No, it is not. Is 5 equal to x? No, it is not. So, but what does it mean? That means 5 is, since 5 is lesser than 14, that means the element is on the right side. The element must be on the right side of 5, right? Of 5. So what we're going to do in this case, we are going to increment low, right? What we do generally, low equal to mid plus 1. If, for example, for example, if we are going to write what? If mat is less than x, right? If mat is less than x, then low equal to mid plus 1 we are going to say, right? Low equal to mid plus 1. So what is mid right now? Mid is 1. So 1 plus 1, 2. So 0, 1, 2. So low will be pointing here. Our low will be pointing here, right? Low will be pointing here. So again, we are going to calculate our mid. 2 plus 3, right? Low equal to 2, high equal to 3. 2 plus 3 divided by 2, which will give us what? 5 divided by 2, 2. So mid is 2 now. Mid is 2 now. Row number, let's calculate row number. So 2 divided by 3, right? Which will give us again what? 0. And 2 mod 3, which is going to give us what? 2, right? So we have our row number, column number, 0 and 2. So what is that? 0 and 2, which is here, right? We're going to compare this 9 with 14. Is it equal? No, it is not. But this 9 is lesser than 14. That means the element must be on the right side. Okay. So what are we going to do? We are going to again update our low. So mid is what? 2. So low equal to mid plus 1. Low equal to mid plus 1. So, so low will be 3 now, right? So low and high will be pointing at the same location. Low and high, right? 3 and 3. So again, let's calculate mid. So mid is what? Mid equal to um, 3 plus 3. 3 plus 3 divided by 2, which is going to give us 3 only, right? So mid is also here, right? Mid is also here. Now we're going to compare it. Now, again, we want to have the row number and column number, right? Row number and column number. So let's have row number equal to mid, which is 3, divided by m, which is 3 again, which is going to give us what? 1, right? And column number equal to mid 3, which is 3, mod number of columns, which is m, which is 3, which will give us 1. So 1 of 1. Oh, sorry, not 1. It is going to be 0. My bad. It is going to be 0. Column number is going to be 0. So row number 1 and column number 0. So which is this, right? Which is this? So we are going to compare with x. Yes, it matches. And hence we are going to return true. Okay. So this is the intuition behind solving the problem. I hope you have got the intuition. Now let's go and code. Okay. Before going to the code, I'll request you to subscribe to the channel, like the video. I have already solved this, but let me reset and let's code together. Okay. So first of all, we are going to have n, which will be the row size, right? And m, which will be the column size, mat of 0 dot length. So first I'll show the Java code followed by C++. Not much difference again between two codes. Okay. So now we're going to have low, right, as discussed, which will be 0, int I equal to n into m minus 1, right? N into n minus 1. We want high to point at the last element. Okay. While low is less than equal to high. Okay. Now mid equal to low plus high. by, okay, rho plus I by 2. Okay. Now, what are you going to do? If mat, sorry, before that, we want to calculate the row number, right? Row equal to mid divided by m, right? As discussed, right? And in column equal to mid mod m, right? So we have our cell position, row number and column number. Okay. Now we're going to compare. If mat of row column, if it equals x, that means you have found the element, then we are going to return true from here itself. Okay. If mat of row and col, if it is less than x, right? That means our element is at the on the right side. So we want to update our row, right? Else, if the element is greater than x, that means our element must be on the left side. So I equal to mid minus 1. That's it. And then finally, what we're going to do? Return false if we didn't find the element. Okay. When, for example, once the while loop breaks, right? That means we didn't find the element. Okay. So we'll return, compile and run here. So let's submit. So yeah, the test cases are being processed. So if you see what will be the time complexity here, it is going to be O of log n into m. Okay, since we are using binary search, right? O of log n into m will be the time complexity. Okay, which is much better than the previous one, which was O of n square, right? So the test cases are passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. Not much difference here. Only difference is size, right? There it was length. So I'll attach the code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.